I'm Adam Moz, and this is Moz Models. The long awaited Neuron II ESC. First off, no, it's not BL-Heli32. Second off, it is programmable directly from the radio. There's an ETHOS Lua script out already. There's more coming. It's going to be integrated into ETHOS and the device config menu in the future. There will be scripts for OpenTX, to my understanding. There's also a web page configurator, but it needs an SDK. So you plug it into an SDK on your computer, fire up the web app, and it allows you to configure everything. So you do not need to have a FreeSky radio to use this receiver, or to use this ESC, sorry. Now, it's pretty standard. You got some nice thick gauge motor wires. You've got two pack wires, again, thick gauge. These things are 12 AWG there, and the motor wires are also 12 AWG. So nice and thick, definitely able to handle 80 volts. The output wiring is a little interesting. So first off, you've got this wire here. That's your Beck output. And I'll be honest, I'm going to send feedback to FreeSky that this really should be an XT30. I will be nipping that off and putting an XT30 on there probably tonight. And then you've got these three wires. And the reason that they're three loose wires is because, first off, there's no positive, there's no Beck. This is the control, the ground for the control. This is your FBus or S port, so that's either full control and telemetry or telemetry. And this is, to my understanding, if I got everything correct, this is SBus or PWM. So it will do PWM, it will do SBus and S port, and it will do FBus. You wire those separately. Next thing, you can wire that up, wire this guy up, and run off a flight pack. Get full single wire telemetry control, and it's going to sync right up. Unlike an Avian ESC, where you do have to get your power in sync. Avians just do not like working with battery flight packs. And don't get me wrong, I actually think the Avian is a great product, but that's one thing that personally just annoys me about the Avian is you really got to run it off the back, your receiver off the back. It's a nice chunky one. There's no open area. This is just a big chunk of aluminum here. And unlike the NeuronII, the original NeuronII, which I have one of those as well, there's a nice little power LED there, and gives you the basic specs. So it's a 10 amp, 5 to 8.4 volt Beck, and this is a 3S to 6S ESC. This is not a high voltage. I understand there is high voltage coming. There's going to be more. This is just 60 and 80. The FreeSky has announced there's going to be higher amperage and high voltage options, as well as, I believe the current plan is a 40 and a 25 on the lower end. I'm looking forward to the 25 as a small ESC for, say, DLGs in concert with the new FB series receivers. But I will be doing a more in-depth video on this once I've got it soldered up and I'm ready to install it in the Maule. The Maule had an ESC failure. It's not an atypical failure for that particular aircraft. E-Flight spec'd a 40 amp ESC with some headroom in there, and then said it was 4S compatible. It is, unless you're unlucky or flying in really hot weather. So I cooked the ESC in flight. I got really lucky. Didn't cook the back. So I was able to bring it back, no damage, put it down, dead stick on an electric. But the ESC side is just cooked. So I will be replacing with this, and hopefully I don't have to replace the motor as well. Welcome back. As you can see, the Neuron II has a few changes from the last time I've had it on video, and I'm just going to go over quickly what I did. The first one is very simple. I put a set of 3.5 mil bullet connectors on here so I can plug the motor in. And then I went and put an XT60 on here. Normally for a 80 amp, I'd recommend an XT90, But this is going in an aircraft that is not going to pull more than 55 or so amps. So I just threw the XT60 on for better battery compatibility with the batteries I'm going to be running in that aircraft. And finally, I took the red JST connector off the Beck and replaced it with an XT30 battery side connector. I have personally given feedback to FreeSky that I think they should drop the red JST and just replace with XT30. That way it matches the receiver line. For example, you've got this TDR18 with XT30s. You've got the power switch with XT30s. Everything else in the ecosystem today is XT30 for receiver level power. So I've recommended to them that they do that, and that's what I've done here. So I've just got a little bit of heat shrink. I like these XT60Is over the regular ones because rather than using heat shrink, they use these covers here, and those provide additional gripping surface when you're plugging and unplugging. I'm just going to push this up here, because the other thing I've done is I've built a custom wiring harness out of a extension, and what this is this is shared ground between the standard servo connector input, which is going to get the two connectors, the yellow and the black, which is up here, from the Neuron. That's for FBus, that's for your control and your telemetry. I'm not using S-Port plus SBus or S-Port plus PWM, which are the two other options. So this will talk to an older radio or older receiver with S-Port and SBus or PWM throttle inputs. But I've also patched in the an XT30, so this is going to provide power and control over a single connector to the SR10 Plus in the Maule. If I was, say, running an SR12 Plus, I would have actually run separate cables, so the power could run into the XT30 connector on the SR12 Plus, and then the control would just run over a standard servo extension to a port that's mapped to FBus. Or, if you want two ports, for example, if you're going to go into an old X8R, you'd run one extension to plug into the SBus out port, and that would carry. I'd use this setup here. That would carry my power, and then I'd run a second single wire connector and it would use this blue one. That's your SBus or PWM input, and then I'd use the yellow one to run into the S-Port signal connector for for telemetry and setup, because the Neuron is configured from a script on the radio. It's looking to be pretty slick, so I'm going to get this installed. But before I do that, I need to make a gear view video using this harness. So I'm going to make that now. And then we're going to move on and we're going to do the install and setup video. I'm not going to show you the install. It's just wedging the ESC in there and hooking a couple of wires up. It's not really relevant but I will, once I get it all in there, we'll power it up and I'll walk you through the setup on the radio. I have updated the SR10 Plus to the latest firmware, which is as of this date, 1.0.8, and I've done the remapping necessary to move my controls over to channels 13 and 14. I'm running in quick mode, so I'm not using 15, and as of 1.08, 16 is not used for panic anymore. I've done a video on mimicking that's quick mode. Panic when in full mode. Panic works kind of the same way. They had to remove panic because if you want to use an R9 receiver as your backup for your Archer Plus, the R9 is going to send RSSI on channel 16. Most of the R9 receivers are hard-coded to do that. It's not configurable, and you don't want your RSSI level turning panic on. And that's what was happening to a few individuals, so they simply removed panic. There's an easy workaround. Panic is just an alternate way of putting the receiver into self-level mode. It doesn't have a separate set of settings. It doesn't have a separate flight mode. It uses all the same gains you set up in your in receiver. Of course, you can't always have an alternate gain setting on channel 13, so you're running higher gains in panic, higher master gain in panic mode than regular self level, but that's something you can configure. So we'll get this set up. We'll go through the setup of the ESC in the model, including setting the back to the right voltage. It's programmable back. You've got direction is settable. There's a few other settings. You can't currently disable braking. Just saying, if you want a freewheel right now, stick with the original Neuron. They have freewheel, but the NeuronIIs don't. I expect that's probably going to come in a future firmware update. There's a couple things that I'd like to see come in future firmware updates. These are new ESCs on the market. The firmware is very functional, but there's a few quality of life items that could be added in the future. So, on to the next video, and we'll have the. I'm actually going to have the X20 because I've moved this model over to the X20. Sorry, X20 Pro for the next video, but if you check out my gear view video on the FreeSky power switch, you'll see the X18's back. The X18 is going to continue to star in many of these videos. And we're back. So I've successfully installed the NeuronII into the Maule. I have it hooked up, and I've done one thing already just so that I can check everything, and that is I've gone into RF system, and I've gone to set, options, and I took my pin 3, which is set to originally, we'll go in there, it was originally set to channel 3, which is my throttle, and I have scrolled all the way down to the bottom and set it to FBus. This is because I plugged the Neuron, that little breakout cable that I showed in the last segment, I plugged that into port 3, which is where the previous ESC, the very basic E-Flight 40 amp programmable ESC, that's where it was plugged in, so I've just used the same port. Now let's go take a look at what we've got. And the last thing I did, just to verify everything, was I flipped my Discover New Sensors on to make sure I got my ESC sensors, and here you can see it. So you got back voltage, back current, ESC voltage, ESC current, temperature, RPM, and consumption. And I've got the aircraft obviously powered on, and you could probably hear it going there. You're not seeing much ESC current or consumption because I don't have the prop on there. I'm trying to be safe. Plus, I've got an almost dead battery. I actually got to throw a little bit of a charge on that battery before I put it back in storage because I've been using it a little bit for this. So, what do we have to do now? Well, the first thing we have to do is we need to go in, and I have the FreeSky ESC Lua script that is downloadable. That is downloadable from the FreeSky setup. I'll have to go check to see what that sensor list is. But there's a number of settings here. We are actually going to do everything except we're going to reverse the rotation direction because it was wrong. It was actually backwards. This is an easy way to do it so you don't, otherwise I'd have to go in, pull the motor, swap any 2 wires to reverse direction, because there's 3 wires, you swap any 2 of them, you'll reverse the direction. Now, with a lot of installs, and my typical install, I've got direct access to the ESC. I really like having that. It's trivial to go in. This Maule, that ESC is just shoved in under the battery compartment. It's extremely difficult to get at, and I have to pull the motor to get at it, and pulling the motor is kind of a pain in the butt. So I'm just going to fix that by setting the rotation direction here. Now, everything else here you see is the default. You can set the PWM minimum to PWM maximum. That's your max and minimum throttle positions. They're not auto-learned, they're hard-coded here. You do have to reset the ESC after that. That's just power off, power on. Soft brake, is on by default. The opposite is hard brake. There is not a no brake setting currently in this firmware. This is the release firmware. 3D mode, that switches you from your minimum throttle being at minus 100, you max at plus 100, to your minimum throttle being at 0 and it going into reverse below that. You can set up custom curves on your ESC to get reversing this way, but you lose a little bit of resolution on the throttle, which generally isn't a big deal. So you're going to get 1024 resolution effectively on each side of your throttle instead of 2048 across it. Or from another perspective, you've got 512 steps instead of in one direction instead of or 512 microseconds, not steps, because it's half a microsecond resolution with high precision PWM. 1024 steps, 512 microseconds. Plus, and the same on the bottom side for your reverse throttle. I don't particularly love this approach. It's same way BL Heli does it. It's great for something like a helicopter, or better yet, a quad running 3D. I don't think it's good for an airplane, but I totally understand why they did it. It maintains consistency between how the Neurons and Neuron IIs function. It's probably the right choice if you're dropping in a Neuron II as a replacement for a Neuron. I do like having the reverse on a separate channel a little bit better personally. Current calibration, that lets you tweak your current readouts so that they match what your watt meter is saying. Trust your watt meter. There's component variation in every ESC. Every ESC is going to read ever so slightly different at the same load, because there's 5% variation in the resistors and 5 to 10% in the capacitors used as components. That means you don't have a perfect calibration. No matter how good the components are, there's always a little bit of drift. This lets you tweak it so you get the exact readouts you're getting on your watt meter. Personally, it doesn't really matter much to me. I'm looking for ballpark numbers. I'm not relying on exact numbers. But if you care about having exact numbers, you can calibrate it just by tweaking that percent, so that when you're pulling a set load, your watt meter says 45 watt or 450 watts, let's say, and the ESC says 458. So you just drop it down a percentage or two until you're reading 450 to match. Current limit, that's 85 amps. I'm not going to touch that, because if I set it down to the 60 or so amps that airplane really needs as a current limit, I'm going to forget it. I'm going to put this ESC in something else, and I'm going to wonder what the heck is going on. So I'm not going to touch that. Doesn't really matter. The ESC is far more capable than the rest of the power system. Spec voltage, 5 volts. I'm using E-Flight or Spektrum servos in this thing. Just the standard BNF servos. I'm not tweaking it. If I was running a build that I built using high voltage servos, or even if it wasn't high voltage servos, I'd probably bump it to 6 volts. Trapezoidal mode, not 100% sure what that does. I will have to figure it out. I'm pretty sure that's essentially doing an offset going in each direction. Physical ID, app group ID, those are FBus or S-port settings. Time gap, motor pole count 14, that's actually right for mine. That's the default. FBus throttle channel, channel 3, again this is a default setting. AETR is your standard. I'm set up AETR, so channel 3 is right for me. But the good point is you can change this. The single thing that drives me nuts about the Spektrum Avian Smart ESCs, you can't change the throttle channel. So you can't run 2 of them. Actually, you can't change their equivalent to SRXL2 IDs either, so you run into a case where not only can you not change that, you can't run 2 of them in telemetry mode because they're using the same ID and they stomp all over each other. This doesn't have that problem. You can sit there, run 2 of them with 2 separate channels. You bump the physical ID by 1, bump the app group ID by 1. It'll work great. High demagnetization protection, that's another setting. If you need it, you'll figure it out. If you don't, just leave it alone. That's for certain very particular setups with motors that need a little bit of delicate setup. So there you go. You've got a ton of settings here. The only one I really see missing as it currently stands is being able to turn brake off and freewheel on. That would be nice for some setups, but we've got that. And now that we're all set up, I'm going to go here, and I don't need RX battery. That was just really a proxy for me to tell when the thing came up. I'm going to go configure widget, and we're going to scroll down, and we want ESC voltage. There we go. And apparently that's the sensor that crapped out. I suspect that's just a low battery issue. Okay. So we've got the ESC seems to have stopped. Interesting. Because I'm running that in FBus mode. Oh, I know what this is. Because we went into the setup, and the setup grabbed... this is something to be careful when you're using those setup Lua. The setup is grabbing the focus for the telemetry feed, so it's basically blocked out the OS. So we've lost all our sensors. Now, when I go and I power cycle that thing, we'll get it back. But I'm not going to bother doing that right now. There's no real need. I've got my basic setup here. I will set up an alert. This is way too low voltage. I actually want to throw that on the charger and bring it up to storage. VFR's 95, 96. That's because this thing's sitting on a metal frame couch. It's not the world's greatest RF environment. It's sitting right next to a big chunk of metal. The receiver, that is. So that's why we're seeing that. Don't worry about it too much. I'm going to make a second page right now. So we've got, like you can see here, I've got Lua RSSI. I'll just go in here, create a calculated sensor. It's power, watt, is ESC current, voltage is ESC voltage, and write logs is on, boom. Yeah, that was way, way easier. So now we've got a watt sensor. So let's go back over here, screen to value. I'm going to go telemetry, power, and actually, yeah. And I want max, because I want to see the max watts I pulled. And then I'm going to go and make another one. And don't ask me why. Okay. That gives, you see if I go back home, I go over there. I got a power max and a power. We've already got our voltage. There's a few more we can, so we'll just value. AC consumption. That really would be all I really need here. So we've got the ESC consumption, my power max, my power. I can throw amps in there too, but actually that's useful to know. So let's throw value, telemetry, ESC current, and telemetry, ESC temp. There we go. So we got your basics. We got our temperature, and yeah, 28 Celsius. That's about what it is in here. I got power max. I got consumption, I got current. We've got our voltage over here. So that's everything. We now have a smarter Maule. We don't have, the level of battery pack telemetry that you get out of a Spektrum Avian, but we do have all the ESC level telemetry and a few things that we can't do on an Avian we can do here. Specifically, the ability to run multiple in telemetry mode at the same time, as well as get consumption. ESC consumption. But that's it. We have a new ESC in the Maule. I will have to balance the Maule out because I did put a heavier ESC in, so it probably needs a little bit of tail weight or maybe reposition. I did shove the ESC all the way to the back versus the further forward positioning, so I gained some of it back. We're ready to fly it again. A little bit of balancing and a couple of charged batteries, and this thing is golden.